Okay, so let's take a look at this. Here's the key. All right, number one. Number one says triangle ABC will be translated 2 units to the right, 6 units up. As you can see, it doesn't tell us to graph it, but I went ahead and graphed. 3 units to the right, 6 units up. 3 units to the right, 6 units up. 3 units to the right, 6 units up. Okay, and so then it says write a coordinate rule. Some of you didn't know what a coordinate rule was. This is the actual answer for coordinate rule. Or I did allow for the vector notation, which is 3 and 6. Okay, either one would be fine. Okay, number 2, what will be the coordinates of the image of point A, which would be A prime, which is right here. Some of you switched around the X and the Y. Got the problem right, but they switched around the X and the Y and put 7, 4. Don't make that silly mistake. I'm not saying anybody's name. Number 3. Again, we are counting over, which is the X, 1, 2, 3, 4, 5, and we're counting up, which is the Y, 1, 2, 5, 2. 5 units to the right, 2 units up. C. Pretty simple problem. All right, let's go to number 4. Number 4, it says triangle ABC is reflected to create triangle A prime, B prime, and C prime. What would be the coordinates? They've already graphed it for you. This is so simple. Right here is C prime. Right there is C prime. You just got to find the coordinate 2, 6, B. Number 5. Probably the most often missed question on the quiz. Look at triangle DEF. Here it is. Triangle DEF will be reflected across a line such that all the vertices of triangle D prime, E prime, F prime are in quadrant 2. Very important. Here's quadrant 1. Here's quadrant 2, something we talked about more than once in class. Here's quadrant 3. Here's quadrant 4. It's counterclockwise. So if it's all in quadrant 2, that means what line of reflection is used to form triangle DEF? That means we'd have to flip it over. So I drew it in. There's the line of reflection, which is the y-axis. Or if you want to give it the equation, it's x equals 0. Got it? All right, move on. Number 6 through 8, use triangle LMN. What will be the coordinates of the image of point M after it is rotated 90 degrees clockwise? Okay, clockwise means it's going this way. It's going this way. That's clockwise. So the coordinate is 8, 1. Here's the rule for a 90-degree clockwise rotation. X, Y to Y negative X. And then it would be 8, 1 would become 1 negative 8. Or you could have just graphed it. We had quite a few people that didn't use the rule, and they just graphed it, and they got it correct. That would be fine. Okay? So M would come all the way down to here to 1 negative 8. What counterclockwise rotation will create the same image as 90 degrees clockwise rotation? Well, you actually don't even need to look at the graph to figure that out. If you look at a circle, if I go this direction, that's 90 degrees. And if I go this direction, that's 270, and you end up in the same spot. So the counterclockwise rotation would be 270 degrees. And number 8, which of these shows the image of triangle LMN after a 180-degree rotation about the origin? That would be B. Here are all the points. L11 becomes -1, -1. M81 becomes -8, -1, which is right there. N85 becomes -8, -5, which is right there. All right, any questions on number 8? Number 9. Which figure has line symmetry? Not R, not L, not G. It has to be W. I even sketched in the line right there. And then number 10, look at this figure. What is the angle of rotational symmetry for this figure? Well, it's not 90, which means, because that would be sideways. It kind of look like an N. It's not 270, because that would just be the other way. So the only possibility is 180. Just flip it upside down. Every question was worth 2 points. 20. And it's already been in the grade book. Questions on the quiz? Anything? All right, keep it. Don't throw it away. We will use that to review when it comes time for the semester final. Turn to page 140 in your book. 140. We are discussing, oh, you need your notes out too. We're going to add some notes here. We are discussing module or lesson 3.3. The title is Corresponding Parts of Congruent Figures are congruent. Corresponding parts of congruent figures are congruent. All right, if you look on the screen, I've got two objects, two brand new, fresh pencils. All right, are those figures congruent? I mean, maybe some real small, minor things that we can't even see, but basically, are those two figures congruent? Okay, so let's start there. Those two figures are congruent. All right? When we conclude that those two figures are congruent, then there's a lot that we can tell from that. Here's one thing that we could tell. The erasers are the same. The letters are basically the same. The thickness or what we would call the diameter, if it's a circle, they're the same. The length of the entire pencil is the same. Number 2 pencil and a number 2 pencil. How many sides are there? Let's count them. 1, 2, 3, 4, 5, 6. It's a hexagon. This is a hexagon. You get that once I know that these two things are congruent, then all the parts of it are also congruent. Does that make sense? That's the lesson. Okay? Now we're going to build on that, but that's the fundamental part of the lesson. That if we know two things are congruent, then so are all the parts. Okay? All right, good. So turn to, on page 140, you see right in the middle of the page a box that says corresponding parts of congruent figures are congruent. Please write that theorem or definition in your notes. Usually theorems are if-then statements. We're going to use this the rest of the day. So I want to make sure you have it down and you understand what it means. Okay? If I'm looking at two quadrilaterals, that means all four sides of one are congruent to four sides of the other. All four angles of one are congruent to four angles of the other. If I'm talking about an octagon, then 8 sides of one is congruent to 8 sides of another. And when we say corresponding, I'm going to show you what that means. It means that certain parts have to match up. We kind of talked about it yesterday. The order matters, how they're named. Turn over to the top of the next page. Looking at your turn, number 4 and number 5. Okay? Your turn, number 4 and number 5, top of the next page. Everyone see the two pictures that are there? Those are triangles, correct? You should see a congruence statement. Mason, at the beginning of the problem. Can you read that off for me? It should say triangle is congruent to triangle. At the beginning of the problem, right under where it says your turn, page 141. Page 141, are you on that page? Okay. Triangle. Yeah. That means congruent, that's right. Congruent symbol. Okay, here's what we're talking about. How many parts are in a triangle? 6. There's 3 sides and 3 angles. Okay? And so S matches to V, T matches to W, U matches to X. Let's go to question number 4. Question number 4 says, find the length of SU. When it just says SU like this, that means it wants the length of SU. That's what they're asking for. Okay? It's not the segment SU, they want the length of it. Alright, so now, just looking at the congruent statement, Nicholas, if SU are those two, what's the corresponding side in this triangle? Very good. So I know, just by not even looking at the pictures, I don't even have to look at the triangles. I know just by the congruent statement that SU is congruent to the X. Colby, do you understand that? Just because of the congruent statement. Jalen, does that make sense? Alright. James, does that make sense? Give me something else that's true. From this congruent statement, James, I've just told you there are 6 parts. There's one of them. What's another thing that's true on this congruent statement? Okay, let's just keep it in the right order. ST would be congruent to VW. I would agree. Everyone hear that? ST is congruent to VW. All right? There's number 2. We've got 4 more to go. Elise, you want to give me one? Good. We got 3 more to go. Millie, you want to give me one? Okay. There's 3 more to give. No. See this congruent statement, Lily? There are 6 parts to that congruent statement. We've already taken care of all the sides. No, we already did that. No. Just this statement right here. Basically, just say that one of the angles is equal to another angle. Which one? In this statement right here, Lily. That's the triangle, correct. But how many angles are in triangle STU? 3. How many angles are in triangle VWX? Okay, which ones are equal? Hasn't connected yet, Lily? Okay, so when we wrote down if two figures are congruent, then corresponding sides and angles are congruent. So here are two figures, triangle STU and triangle VWX. If the corresponding sides, which we've already taken care of, 1, 2, and 3, if those are congruent, and corresponding angles. So now I want to name the angles which are congruent. So we've said ST is congruent to VW, is in the same position how it's named in the statement. So what I'm asking, Lily, is what angles are congruent in this statement? Very good. There's one. Riley, you want to give me another one? She said T and W. There's 3 angles here, and there's 3 angles here. She's already said the T and the W. What are the other 2 angles? What did you say? X and which one? U and X. That's right. Angle U is congruent to angle X. Then we've got one more. Hope. Last one. Which one's not named? They've said T and W, and U and X. Which one's left? They've already told me that T is congruent to W, and U is congruent to X. What has not been said? Yep. Angle S is congruent to angle V. Does everybody see the 6 parts? Okay. Now that we know that, we're going to use that pretty much all year. Corresponding parts of congruent figures are congruent. Hi, Mr. Sakowski. Now, we're not in triangles yet, but we're going to get there. Yes. Okay. She's right here. Okay, so let's move along with that. We're trying to find in this problem what the length of SU is. We know that it's equal to the length of VX. All right, so look in the diagram. What's the length of VX? Does it tell us? 43 feet. Well, if SU is congruent to VX and VX is equal to 43, what can we conclude? What does SU equal? 43 feet. Yes, it is that easy. SU is equal to VX. How do I know? Because they are corresponding parts. SU, VX, corresponding parts. Look at the diagram. They match up. What's the length of VX? What's the length of VX? 43. So that means SU is 43. All right, let's do number 5. All right, same diagram, but on number 5 they want us to find the measure of angle S. If I look at my congruent statement, I know that the measure of angle S is congruent to the measure of angle V. Looking at the diagram, what's the measure of angle V in the picture? How much? 38 degrees. Well, if that's 38, then I know that the measure of angle S has to be equal to 38 degrees. It is that easy. Okay? Actually, you know what we've just used? We've used the transitive property. S is equal to V. V is equal to 38. Therefore, S is equal to 38. That's called the transitive property. You don't use it much in algebra, but we do use it a lot in geometry. Colby, does that make sense? Okay, good. Since Colby said it makes sense, I want everybody to do number 6 and number 7 on the next page. It's not because Colby said that. We were going to do it anyway. If you're stuck, just watch me, because I'm going to do it too at the same time.
I'm not stuck.
Then keep working. If you're not stuck, keep working. Here's my congruent statement. That's going to help me out a lot. Trying to find LM. Well, when I look at the congruent statement, LM right there. Since I know LM is equal to GH, I can set up an equation. What's the length of LM? Look at the picture. 6x minus 13. What's the length of GH? Look at the picture. 4x plus 3. So I can substitute and now I'm going to solve the equation. Algebra. X equals 8. Does that solve the question? No. What were they asking for? They're asking for the length of LM. Well, we know that LM is equal to 6x minus 13. Well, since we know what x equals, we're going to do a little bitty substitution and put 8 in for x.
So 6 times 8 minus 13.
6 times 8 minus 13. That's right. Don't get your calculators out. You don't need them. We're just doing 6 and 7 on the next page, Hope. Laney, you good? Understand it? Okay. All right, let's go ahead and do number 7. If you're feeling confident, go ahead and do it on your own. Measure of angle H. All right, I don't even have to look at the pictures. I can look at the congruent statement, and I see that H is there, and that corresponds with M.
I don't see it.
You don't see what?
I'm still off.
Do you see the congruent statement?
Sure.
What I'm pointing at right here.
Yeah.
You see that these are named in order. You see that? Which one is second? H is second. That's what we're trying to find. Which one is second here?
M.
So we know that H is congruent to angle M. Just because it's named in the same spot. We don't even have to look at the picture, and we can conclude that. Sometimes looking at the picture can confuse you more than help you. Okay? Because the congruent statement says it, then we know that H is congruent to M. Now, look at the picture. What's the measure of angle H? It's kind of hard to see. It's a degree, but it's usually got a parenthesis with it. When I look at measure of angle H, it looks like it's 9y plus 17. Do you see that, Ethan? Okay. And then what's the measure of angle M? Again, it's got a parenthesis. 11y minus 1. Good. You just generated an equation. Now we got to solve for y. Now we got to use algebra. We solve for y. We end up with y equals 9. Is that the final answer, though? No, not at all. Because we're trying to find the measure of angle H. And we know that that is equal to 9y plus 17. So what do you think we need to do, Mason, with this y equals 9? If this is the measure of the angle that we're trying to find, and we know that y equals 9, how are we going to find what it equals? What do we need to do? Any idea? Okay. Ethan, what do you think?
You do 9 times 9 plus 17.
Okay. Let's explain what that is first. We need to substitute the value of y into that equation. So it becomes 9, and as Keithan said, times 9. So it's not y anymore, it's 9 plus 17. That make sense, Mason? So it's like in algebra, we would stop here usually. We would know what the value of the variable is, but we don't in geometry, not very often. We usually keep going because we got to find the length of a side or the measure of an angle. And so we have to substitute that in. Now let's use our noggin. 9 times 9, 81, plus 17, and we end up with 98 degrees. Got it? Okay, so a lot of algebra. Got to use geometry to kind of set up the equation. Then you got to use some algebra, and then geometry to finish off. Question? Okay, let's keep moving along. We're going to start our discussion on proofs. In your notes, I want you to write this down. Proofs have some different parts. They have a given statement. Usually they have a diagram. They have what we're trying to prove. And the structure is usually a 2-column. And the 2 columns look like this. Statements, reasons. Okay, so this is the introduction to proofs. We have a given statement, we have a diagram, we have what we're trying to prove, we have the structure is of 2-column statements and proofs. Statements and reasons for the proof. In the reasons category, so over here, the only possible things that you can write are, you can use what's given, you can use postulates, you can use properties. What properties are we talking about? Like the subtraction property of equality. Oh, hi, Bo. Welcome. We're on page 142. We're going to turn to page 143 shortly. Properties, postulates. You can use theorems. You can use definitions. I'm going to cautiously write this one. You can use diagrams, but usually got to have a reason for it. Postulates we've started talking about already. Properties, a lot of those have been from algebra, but we've written a lot of them down already in our notes. Theorems we start using a lot more as we keep going here. Definitions, we just wrote a definition a little bit earlier. If two figure corresponding parts of congruent figures are congruent, corresponding angles, corresponding sides. That's the definition. Okay? So, statements are, you start at the given, and you give your argument or your justifications to what you're trying to prove. That's the structure of proofs. That's the nuts and bolts of it. Okay? Why do we do proofs? To help you learn how to think logically. I've been given a statement. I want to prove something else. How can I get from here to there? Okay? Well, in order to get to there, I've got to show that this is true. If all those things are true, then what I'm trying to prove is true. Okay? So it helps us to get from one point to what we're trying to prove. All right? You'll see. As we go through, it'll make more sense. I'm going to tell you now the most difficult part of proofs are these reasons. Because as we've discussed them, you have to recall them. And we use them in the proofs. All right? Okay. That being said, let's move on to page 143 at the top of the page. You can see example B. At the top of the page. Pictures, I'll try and do my best here, maybe. Not too bad, actually. I'll take it. These are hard to draw. All right, so far this is just the given information. The given says that quad quadrilateral JKLM is congruent to quadrilateral NPQR. Why is that important? Because that means that there are 4 sides and 4 angles which are congruent. So I'm not going to go through it like I did with everyone before, but I'm going to do it real quickly. J is congruent to N, K is congruent to P, L is congruent to Q, M is congruent to R. Angles. Segment JK is equal to NP. KL is equal to PQ. LM is equal to QR. And JM is equal to NR. 4 and 4. There's 8 parts that are congruent. Okay? All right, so now, what else? They also give us that interesting that angle J is congruent to angle K. Now, one thing that I like to do is when I look at this, that tells me that this angle and this angle are the same. I like to make the note in the diagram from what's given. Okay? Now, what am I trying to prove? This is going to give me the direction that I'm going to go. I'm trying to prove that angle J is congruent to angle P, which is way over here. Wow. So we know J is congruent to K. But how in the world can we set it up to angle P? Okay, so back to your notes. All right? So in your paper, not in your book. Back to your notes. Here's a technique. Guys, I've taught geometry for 15 years. There's no one way to do a proof. I'm going to teach you a few different approaches, and you're going to use them all in order to try and do the proofs. Here's one technique. Work backwards. Work backwards. Okay, what does that mean? If I'm trying to prove something, what would need to be true in order for that to be true? Okay, it's kind of like this. If Andrew cleans his room, he gets an allowance. Okay, if I'm trying to prove that Andrew gets an allowance, what must be true?
You give him money.
No, he better clean his room. Do you see how I just worked backwards? And that's all. That's a technique that we work backwards. If what we're trying to prove is true, then something should have happened beforehand. Okay? Very conditional. All right, now, so let's come back down to here. This says prove that angle J is congruent to angle P. Okay, well, let's see. Let's set up our diagram. Our structure. We have statements and we have reasons. All right, statement number 1 is the given. Quad JKLM is congruent to quad NPQR. What's my reason? Go ahead and write it in. It's given. That's an acceptable reason. It's given. When it's given, it's accepted as true. Look at step 2. Angle J is congruent to angle K. What's my reason there? It's also given. There's step 2. All right, now step 3. They say that angle K is congruent to angle P. All right, now we got a problem. Why? Why can we say? Why can we justify that that's congruent, that K is congruent to P? That's this angle here and this angle here. Why? Why? Question mark. Why is K congruent to P? What do you think, Nicholas?
It's because they're the same part on the congruent side.
That's right. We just talked about it. We put it in our notes. They're corresponding parts of congruent figures. Now look at this. See my congruent statement? Where's K at? There. Where's P at? Are they in the same position? Yeah. So my reason, I'm just going to write it out. Corresponding parts of congruent figures are, I use a little bit of shorthand, are congruent. It's okay to abbreviate. I use the symbol congruent for the word congruent. Corresponding parts of congruent figures are congruent. All right. Last step is what we're trying to prove. They already have it. Angle J is congruent to angle P. Our reason, transitive. No homework for tomorrow. We'll pick up there.